At the heart of modern technology is the semiconductor. From basic appliances to cutting-edge AI systems, semiconductors are the silent force behind every click, every beep, and every tap that makes up our modern world. In today's economy, there are few components more crucial than semiconductors, also sometimes referred to as microchips or integrated circuits. They're ubiquitous, powering all of today's electronics, like computers, appliances, cars, and so much more. However, beneath this marvel of modern engineering lies fragility, a supply chain susceptible to geopolitical tensions, trade disputes, and unforeseen disasters like the COVID-19 pandemic. And its stability is more than just an industrial concern. During the pandemic, consumers around the world experienced firsthand what disruptions to the semiconductor supply chain meant after it wreaked havoc on the entire economy. But before we dive deep into the complexity and fragility of the semiconductor supply chain, we need to understand a bit better the market that many are calling the next trillion-dollar industry. You see, semiconductors are fundamental to modern electronics, acting as the brain of devices. The demand for them has skyrocketed with new technologies like 5G, the Internet of Things, autonomous vehicles, and especially artificial intelligence. These technologies require sophisticated semiconductors, capable of efficiently handling complex computing tasks. Because they're so pivotal across so many industries, semiconductors represent a massive booming market. Most of that growth is driven by automotive, data storage, and wireless industries. In the automotive sector, chips enhance vehicle performance and safety through advanced driver assistance systems. Meanwhile, they're foundational to all information and communications technology, especially computing and data storage. There are reasons why, across just about every microchip in production, from memory chips to logic chips and more, the strong growth of the semiconductor industry is set to continue. With semiconductor deals hitting record highs both in dollars and volume, sales have also been following suit. In 2018, sales totaled $481 billion. That grew by more than 20% to about $600 billion in 2021. With aggregate annual growth that could average from 6 to 8% a year up to 2030, the result is a $1 trillion industry by the end of the decade. Altogether, the global semiconductor industry is a key growth sector in the global economy, and it's quite important for the US economy as well. In fact, the US semiconductor industry alone accounts for nearly half of the entire global market share. It's no surprise then that microchips are a key US export. Worth $62 billion in 2021, they were fifth highest among US exports, behind only refined oil, airplanes, crude oil, and natural gas. Semiconductors also constituted the largest share of US exports of all electronic product exports. Yet, you'd be forgiven if you thought the US semiconductor market was manufactured entirely in-house. Although the US semiconductor industry maintains more of its manufacturing base in the US than any other country, in 2021, that amounted to only about 43%. Other manufacturing locations for US headquartered firms are mostly spread between Singapore, Europe, Taiwan, and Japan, but on the whole, that percentage is shrinking. Due to the ambitious chip manufacturing incentives offered by other governments, the share of semiconductor manufacturing capacity in the US fell by more than 10% over the past 8 years. What this means is that the US's grip on arguably one of the most important industries in the world is slipping, and when it comes to potential issues posed by the industry, that's just the tip of the iceberg. This brings us to the broader global semiconductor market and its biggest vulnerability: its fragile supply chain. In 2021, the world watched as semiconductor shortages ravaged the global economy, and pundits were quick to place the blame on disruptions to the industry's already fragile and weak supply chain. Many called it a crisis. The shortages were disastrous, costing billions of dollars. But why? How could the supply chain behind one of the world's most important industries be at fault? And why was it so fragile and weak in the first place? Let's break the semiconductor supply chain down step by step. What might be considered the first stage, although it's often left out of the broader picture, is research and development. Globally, the semiconductor industry spent $64.6 billion on R&D in 2018 and rose to $90.6 billion in 2021. This represents a massive amount of spending compared to other industries. However, the vast majority of spending comes from the US, which held a commanding lead with $38.7 billion in R&D spending in 2018. By comparison, Chinese semiconductor firms spent only $2.6 billion on semiconductor R&D. As a percentage of semiconductor sales put towards R&D, the US again leads all other countries at 16.4%, with Europe close on their tails. Meanwhile, China lags far behind at only 8.3%, about half as much as the US by percentage. After R&D, of course, comes the design and production phase of the supply chain. This is where things get complex. Collectively, the United States, South Korea, Europe, Japan, Taiwan, and China perform almost all of the world's semiconductor design. The US takes in about 43% of all chip design revenue, although given its expertise in memory chips, the next in line is South Korea at 21%. And to be clear, design is no small part of the supply chain. Chip design makes up a whopping 53% of all industry research and development, 13% of the industry's capital expenditure, and a full half of the value added. Nonetheless, after the design phase comes manufacturing, which starts with materials. To fully understand semiconductor manufacturing, we have to look at it geographically, and wafer fabrication materials are fairly spread out across the face of the globe, from photomasks which come predominantly from Taiwanese firms to silicon which is more distributed. The landscape is fairly Asia-centric. Demand, similarly, has become dominated by Asia in recent years, especially China, which has become the largest single-country market on Earth for chips. Sales to the country have multiplied from $39.8 billion in 2001 to over $343 billion in 2021. Zoom out, however, from chip makers' headquarters to manufacturing and assembly locations to the final point of sale, and the life cycle of each chip is fully dispersed across the globe. The top countries leading in semiconductor manufacturing include Taiwan, South Korea, Japan, the United States, and China, with some production also coming from Europe. Let's quickly look at each in turn. First, Taiwan, led by Taiwan Semiconductor Manufacturing Co., considered by some to be the world's most important company. It's a global leader in raw semiconductor manufacturing, with TSMC alone manufacturing over 50% of the world's semiconductors. Given its importance, which makes up 15% of Taiwan's GDP, the chip industry is often called Taiwan's Silicon Shield, since it gives the world a big reason to defend the island. Then there is South Korea. With giants like Samsung Electronics, it's also a significant player in chip manufacturing. Samsung functions as both an integrated devices manager, IDM, and a foundry, providing semiconductors for other companies as well. The company even just committed a $230 billion investment to help the country build the world's largest chip manufacturing facility in the Greater Seoul area. Cross the East Sea, and Japan hosts more than 100 semiconductor fabrication plants, clear evidence of its foothold in the sector. It's a foothold that has declined precipitously in recent years, but it's growing once again. And then, as we've mentioned, you have the United States. The US was once a leader in semiconductor manufacturing, but today it's much more reliant on fabs across the Pacific to churn out the advanced chips it designs. It still maintains its competitive advantage in innovation, particularly in semiconductor patents and their outsized impact across the industry. In manufacturing, though, it continues to lose ground. Despite a massive decline in its global chip manufacturing capacity from 37% in 1990 to around 12% in 2021, the US remains an absolutely key player, considering its companies hold approximately 46.3% of the total semiconductor market share. However, this is made all the more concerning by the actions of its greatest geopolitical rival, China. Aiming to become self-reliant in semiconductor manufacturing, it's working on expanding its own manufacturing capabilities, with a vision to produce up to 25% of the world's semiconductors by 2030, as opposed to the 15% it produces today. Collectively, these countries and their fabs make up the bulk of production for chips. At this point, we've traversed just about the entire scope of global semiconductor manufacturing, but we're still missing one key part, potentially the most important of all. And it's a country you might not expect, the Netherlands. The golden screw, so to speak, that supports the entire global semiconductor industry is a small company based out of the equally small town of Veldhoven, called ASML. And it produces something no other country or company can do. They're called EUV lithography machines, and they're the most expensive and critical step in making the advanced microchips that power our digital world. EUV lithography is essentially a special technique used to make chips. sort of like a high-tech printing process where the machine, made only by ASML, uses a very specific kind of light to draw tiny detailed designs on silicon wafers. These designs are what make the microchips work. This process is expensive and complex, with each photolithography machine costing an incredible $200 million. In fact, their next-level machine is expected to have an even bigger price tag, over $300 million, and ASML has the monopoly on them, but not for lack of trying. The machines, which are then sold to the manufacturing facilities and fabs that we mentioned earlier, are so mind-bendingly complex that no other company has ever been able to rival ASML. Camera makers Canon and Nikon also produce photolithography machines, but ASML alone has harvested the EUV light that makes the most advanced chips possible. And they're so critical that some countries, like China, have become stockpiling them for fear of being shut out in recent trade disputes. The result? An absolute linchpin in the semiconductor industry, without which the world's ability to produce advanced chips would simply fall apart. Altogether, the semiconductor supply chain is a complex international network, with a single chip potentially traversing more than 70 international borders before reaching the consumer. This lengthy journey involves over 500 discrete stages, from design to equipment and materials to manufacturing. No single company or country currently has the capacity to independently execute all roles in the supply chain for all types of semiconductor required by a modern economy. And to politicians and economists everywhere, this is cause for concern. For one, the entire supply chain is dependent on a few key links, like ASML with its lithography machines, or TSMC, which dominates chip manufacturing. Another inevitable vulnerability lies in the geographical dispersion of its materials, components, and manufacturing facilities. This geopolitical spread, while it offers some advantages, also exposes the supply chain to many potential bottlenecks in production and transportation logistics. A prominent case in point is the global shortage of chips that wreaked havoc in years past. The shortage was a glaring testimony to the economic repercussions of supply chain disruptions, with an estimated $240 billion shaved off the US GDP in 2021. Although it caused a cascade of financial implications across various sectors, none were more effective than the automotive sector, which has come to rely far more on advanced electronic components. And while COVID-19 and its disruptions have passed, the semiconductor industry isn't insulated from global politics. The semiconductor supply chain is entangled in complex geopolitical dynamics, notably between the US and China. The US has curbed China's access to advanced semiconductor technologies, fueling the ongoing chip war and rippling across the global semiconductor supply chain. In its wake, surveys among senior decision makers in leading semiconductor firms show a panic spreading about supply chain risks. Facing these challenges, the semiconductor industry, along with governments, have been devising stabilization strategies, such as cost-cutting, delaying capital expenditures, and focusing on diversification and digital transformation. Diversification is particularly important for mitigating shortages. Meanwhile, policy initiatives like the U.S. CHIPS Act and Europe's Semiconductor Alliance, which are backed by substantial funding, aim to foster domestic production and enhance supply chain resilience. Other nations have turned to stockpiling critical materials and components. Some moves are considered a short-term strategy to buffer against disruptions, but are far from a cure-all. In the end, one thing is clear. The delicate nature of the semiconductor supply chain is a serious concern in our tech-saturated era. It's like a well-set domino chain, vulnerable to all kinds of disruptions, be they geopolitical skirmishes, economic strains, or rapid changes in supply and demand. As the nerve center of modern technology, it's crucial to shore up the semiconductor supply chain. Looking forward, the roadmap is uncertain, but through collective effort, industry and governments can collaborate to get it done. It's never been more important that they do. Thanks for watching.